Lesson 5, limits of transcendental functions. So we are still talking limits. We're talking limits of some specific functions. For example, we're going to talk about the exponential function. We've got we'll talk about those two special trig limits that we briefly mentioned the other day. And going along that line. So, if you research the definition of a transcendental function, you will find this explanation on Wolfram's MathWorld. A function which is not an algebraic function, in other words, a function which transcends or cannot be expressed in terms of algebra. Examples of transcendental functions include exponential, trig functions, and inverse functions of both of those. Okay? So, analyzing limits of exponential functions. Recall that exponential functions are written in the form y equals a times b to the x minus h plus k. Now, to be honest, when I think of exponential functions, the very basic, I think of, like, that's probably how we actually stated it back in algebra or pre-calc. It's just y equals a times b to the x. The minus h, the plus k, that's what we learned about in algebra, though, when the minus h is how far the graph moves left or right, and the plus k is how far the graph moves up or down. Okay? So, you need to be able to find the limits of exponential functions without the aid of a graph or a calculator. So, we're going to kind of investigate, how an exponential function works, okay? The rules of it, how we know which way it goes, what flips it up and down, those type of things. We're going to evaluate. Now, we're going to start the easy way out. We're going to start with graphs. Okay, but then that means we're going to go to, okay, how do we do this without looking at the graph? And when we talk about how do we do this without looking at the graph, in my brain, it's kind of visualizing the graph. So, okay, I am going to, there's a lot of pages here, so let's see. Okay, example A. You have the graph of f of x equals 3 halves x, or 3 halves to the x minus 1 minus 3. Now, should we start with the basic of what a basic exponential graph looks like? I mean, if we go back to pre-calc, lesson 1.2 or 1.3, one of your graphs was y equals, did we use it as e to the x? Is that what we used?
Sure.
Or did we say, I don't know. But either way, your exponential graph was just this basic increasing graph there, okay? That was your basic exponential graph. So as you look, these are all versions of that graph. So 3 halves to the x minus 1 minus 3. Well, 3 halves is a little bit bigger than 1, so it's still an increasing graph. It just makes it increase a little steeper, if I recall. The minus 1 means the graph just scoots slightly to the right. It's not really going to affect what you see here. The minus 3 scoots it down 3. That affects what you see big time. So, what's the limit as x approaches negative infinity? I agree. Okay. I agree. -3 because you're approaching, that's an asymptote drawn in there, right? A normal exponential function does not cross the x-axis. Because we move this down 3, it now does not cross y equals -3. And as we approach positive infinity, as you go right is going up. Now, a couple of things. This is, because it is moving up and to the right, I'm going to throw out the word that this is an increasing function. Okay, so it is an increasing function. Besides the fact it's an increasing function, I want to point out to you that the base being the b value, so 3 halves, that base is greater than 1. Because that base being greater than 1 will start it as a increasing function. Okay, it keeps it going to the right, so to speak. Let's see, I guess we're going down the page, aren't we? If we go in order. B. So, look at some of the pieces here. You got negative e to the x minus 1 plus 2. Well, the x minus 1, that minus 1 moved it right 1. You can't really tell left or right that little. The plus 2 is going to move the graph up 2, but that negative out front reflected it across the y-axis. Okay? So it would have reflected it across the y-axis because the negative is on the, or excuse me, x-axis. My apologies. We're reflected across the x-axis because the negative is out in front of the equation. So, limit as x approaches negative infinity.
2.
Limit as x approaches positive infinity.
Negative.
Negative infinity. Now, as this one, as we talk about this one, b again. So, b was 3/2 here. B is this e right here. And that negative is a reflection, okay? So we're just looking at the e. That b is still a value. E is still greater than 1. Okay, we're not paying attention to negative. It's just then that it became, b is greater than 1, but it became a reflected graph. Because it's a reflected graph, my graph isn't going up anymore, it is going down, so this is a decreasing function. Okay. C. So we have 2/3 to negative x plus 1. Limit as x approaches negative infinity. It's approaching 1 from above. Limit as x approaches positive infinity. As it goes right, it's going up. Now, what do you notice about, what is the b value this time?
2/3.
2/3, which as you look at that, it looks like b is less than 1. Because 2/3 is less than 1. However, here's the catch, guys. What's up on that x? A negative. What happens? How do you deal with a negative exponent?
You switch them.
You switch them, right? Normally we say if it's on top, it goes to the bottom. If it's on bottom, it goes to the top. So if it's already a fraction, then it just becomes 3/2, or 3/2 is the first if you want. And what do we know about 3/2? Well, that is greater than 1. Okay? So that negative makes a difference. And so this is still an increasing function. Notice these were, well, no, that middle one wasn't, but, so increasing function there. Okay? D. Limit as x approaches negative infinity. Limit as x approaches positive infinity.
-3.
Okay. And it's -3 because my graph moved down 3. Are you catching a connection, guys? That, one of the ways, if your graph moves up or down, one of your limits is going to be equal to that value of whether your graph moves up or down. The other limit is going to be equal to either positive or negative infinity, depending if this graph is going up or if it's going down. So, in this case, what do you notice about b? B is 1/2, so it is less than 1. And notice, what is my graph doing this time? As we follow it to the right, it is going down. So this is a decreasing function. What?
Do we have a drill today?
We're drilled out, thankfully. Okay, E. Limit as x approaches negative infinity.
Negative.
Negative infinity. Limit as x approaches positive infinity.
2.
2. Notice my graph moved up 2, yes? Okay. Move left 3. That doesn't really affect anything. This negative out front reflects across the x. So a negative out front of the equation reflects across the x. A negative on the x, like this one down here, a negative on the x reflects it across the y. What is b this time? 1/2, so it's again less than 1, and it is increasing or decreasing? Increasing. Okay, so starting low and going up. Limit as x f. Limit as x approaches negative infinity. Positive infinity. Limit as x approaches positive infinity.
Negative 2.
Negative 2. And what did my graph do? It moved down 2. Now, what would you talk about b here? Yeah, because b is 1/2, and it's because there's a reflection across the y-axis, okay? So it starts off as 2, but there's a negative, and 2 to the negative 1 is 1/2. Well, that puts b being less than 1, if you will, or you could say between 0 and 1. When we talk about less than 1, I guess I should be specific and say it's between 0 and 1. And this graph is then a decreasing. Okay.
So you said when it's less than 1, that means it's between 0 and 1.
Yeah. I only did that on the last one in my page for whatever reason, but
So like it can't be negative.
we don't. The negative, so a couple of these, like we had that negative out front, but that's just a reflection. It doesn't go on that specific number. So. Okay, I'm trying to think. Was there something else? Okay, why did I throw that? Why is that written in my notes? Do you guys remember the vocabulary words bounded and unbounded?
Yes.
Okay, or bounded above, bounded below, yada, yada, yada. Okay. So, I have it written on D, so I have a feeling I was just kind of trying to do it as a review, so to speak. But as we look, I'm just going to look at D because that's the only one I have written on here. So as a review, this graph, as it's going up, what do we know about up in terms of bounded? Unbounded. Okay. So we can talk about this one being unbounded above, not bounded, or I have written unbounded. What about below? It's bounded, yes. It's running along that asymptote. So just kind of a little bit of remembrance there. That this one is, well, I guess I'll say bounded below first, not what I was going to put first, and unbounded above. Okay, so just vocab things that I know I taught you that in pre-calc, but on the flip side of that, the bounded questions on the quiz or test or whatever did not go well at the time. So, okay. And if you didn't notice, these left all start off as exponential growth functions because b was greater than 1. These left were all start off as exponential decay because b is less than 1. Okay, what just happened? Did you see that? Basically, the end behavior of any exponential function tends towards 3 places. Okay? Basically, what kind of answers did we have?
Infinity, or
Okay, so we had infinity, we had negative infinity, and then the other one was it tended towards a number, and that number was the horizontal asymptote, if you will. Okay, so how do I have it written? I guess I have it written, so based on the y equals a times b to the x minus h plus k, you could write it as y equals k, because it's that number going up or down. You could put it as y equals b, which just indicates a horizontal line, okay, or horizontal asymptote. That's, you know. However you want to put it there. Okay. In pre-calc, I referred to pre-calc, we learned the following rules without considering the behavior for negative a values. So again, this is where that value out front is positive, otherwise it's a reflection. So if a is greater than 1 and b is bigger than, or try this again. If a is greater than 0, so it's positive, b is greater than 1, f is going to be increasing, going up, and b is your growth factor. Whereas, again, assuming a is positive, b is between 0 and 1, f is decreasing, and b is the exponential decay factor. So we talked about growth and decay, I know in Algebra 2 and a little bit in pre-calc. So, growth and decay are not synonymous with increasing and decreasing. Okay, we can have one and not the other. So consider the behavior of the function in relation to the horizontal asymptote. Notice whether the function is moving away from or toward the horizontal asymptote. Okay, so is it going down towards it, or is it going up towards it, or, you know, all the different options. And also what affects is a negative coefficient on x due to the function behavior. We talked about negative coefficient would reflect. Okay? Now, example 3 asks us to use the equations from example 1 to complete the table below. Some of this information we already have on the previous page, but we can also kind of try and visualize. I'm trying to remember, did I have them? Are we flipping back, or are we trying not to flip back? I don't remember. Yeah. You will see me keep rewriting this y equals a times b to the x minus h plus k. So in our growth examples, the first one, f of x equals 3 halves to the x minus 1 minus 3. Our base. What is our base here? 3 halves. What was this graph doing? Increasing or decreasing?
Increasing.
Yeah. If it's a number greater than 1, as long as it's not reflected, it is going to be increasing. Okay, and our base is 3 halves. There's no negatives, so there's no flipping happening. So with that in mind, as x approaches negative infinity, so as x goes off to the left, it's going to approach this k value here, yes? Negative 3. As the graph goes off to the right, it's going to go to positive infinity, yes? Okay. Okay, second one. F of x equals negative e to the x minus 1 plus 2. What is my base? E. Okay. Increasing or decreasing? Okay. And why is it decreasing? Yeah. That negative, so the fact that there's a negative out front, that's the idea of a is negative 1. And when that negative is out front, it's going to reflect it across the x-axis. So my graph that was going up like this is now going to go down like that. So that's decreasing. Limit as x approaches negative infinity?
Negative
No.
2. Oh, yeah.
2. As x approaches positive infinity? There's the negative infinity. Okay. And f of x equals 2/3 to negative x plus 1. What is our base?
3/2.
Okay. It looks like 2/3, yes? But it's 2/3 to a negative, which does make it 3/2. What you need to realize, and this is something I should have said, in this basic form, what do you notice about x? It is x minus h. It's positive x, yes?
Yeah.
X cannot be negative in your basic form. So to talk about what the base is, you need to make sure you have a positive x exponent. Positive x exponent? Okay. Increasing or decreasing? Increasing, because when you have that base of 3/2, we're going to be going back to increasing there. Limit as x approaches negative infinity?
1.
1. Limit as x approaches positive infinity? Infinity. Okay. Okay, bottom section. F of x equals 1/2 to the x minus 2 minus 3. What's my base? 1/2. Since my base is 1/2, what do you know about this graph? Okay, it's decreasing. Anytime your base is less than 1, automatically start off by thinking that instead of this graph going up to the right, it's going to go down to the right. Anytime that base value is, until you get other reflections or stuff thrown in. But that's kind of my starting step. Limit as x approaches negative infinity? And as x approaches positive infinity?
Negative 3.
Okay. The negative of 1/2 to the x plus 3 plus 2. Base is 1/2. Increasing or decreasing?
Increasing.
Because?
It's the negative is out front, so it's reflected.
Okay, that negative is out front. It's going to reflect us across the x-axis. So even though it was increasing or decreasing, now it's going to be increasing.
So would that equation be growth actually?
I don't think so. I think this is where this is where I'm a math teacher. And exponential or growth and decay more falls into the science realm, but it falls into the math realm a little bit, and this is where I am going to hesitate. I'm going with somehow, I don't know the exact answer, somehow it's still decay. And I mean, her comment up above with that growth and decay are not synonymous with increasing or decreasing. Okay, so just because that one became increasing does not mean it changed from decay. And I think it's based on this B value here is what still says it's a decay factor. Okay. I don't know I know that's kind of vague. I don't know the exact answer that you want, if that is a fair answer. Okay. Maybe a good thing for me to look into, because now you've got me curious too. But, okay. Limit as x approaches negative infinity.
Mm,
Negative
And as x approaches positive infinity.
2.
Okay. Last b value.
1.5.
A little consistency here, huh?
Yes.
Yeah. B looks like 2, but there's a negative exponent. And so that makes it 1/2. Remember, we can't have a negative exponent in our standard form here. What's that mean? Because that b value is between 0 and 1, we are decreasing. As x approaches negative infinity, and as x approaches positive infinity, negative 2. Okay. Now, that you're kind of doing, I didn't see anyone flipping back, so I think you kind of had the idea of what we're doing. So now we're going to find some limits. There's no graph. Okay, we're using our brains for the graph. There's no calculator. Okay, our brains are the calculator. They're going to graph it.
Oh, goodness.
So
Ooh.
you got this.
Whoa.
Find the limits of each of the following exponential functions.
Limits.
Yeah, limits. What else would we find?
Limit as an x approaches negative infinity.
So, limit as x approaches negative infinity of negative 3 times to the x plus 2. So at this point, I'm pretty much going to start analyzing and thinking through everything we just did on the last problems. You know, what's b? What's your transformations, reflections? You know, basically, I got to sketch a graph is what I've got to do.
lazy kid, huh?
That's why I lived outside.
Because you heard that starting to. I wondered what you guys were like focused on. Okay, so what kind of things are you seeing here?
B is less than 1.
And officially, I did start here writing on my notes. It's between 0 and 1, yes. So if b is between 0 and 1, that automatically means that this is a
Okay.
decay. What else do we need to notice? It's a reflect, yes. My a value is less than 0, so there's going to be a reflection. Okay. Okay, I've got a visual going on in your head.
Yes.
And here's my thing. A decay for me says, okay, I know decay looks like that. But then I'm going to reflect that. When I reflect that across the x-axis, now it's underneath. And what's the other piece of this? The graph moved up to. Woof. Oh, good enough. I kind of started to, I hit the asymptote, but something like that, right? What was the question?
Which is negative as x approaches negative
As x approaches negative infinity, what do we think?
negative.
Negative infinity. Okay. And officially, we can also say that this graph was increasing. That's the other thing I've written down. But, you know, that's the stuff you're reasoning through. And again, I'm still thinking y equals a times b to the x minus h plus k. Won't let me write on the recording board. Okay. B.
Wait.
B is less than
1 over e.
1 over e is less than 1.
This one is. That's why I'm having to process through here. Okay, so, and as I think about this one, it's that you guys are seeing the negative, which is good. What we've got to think about is I'm going to make you think that if we take this negative out, it's x, factoring that negative out, x minus 1, if you will. Okay. And so, and of course, there's still the minus 3. But yes, as you guys said, e to the negative 1 is going to be 1 over e. So e is that 2.718 number. 1 divided by something like that is going to be some kind of decimal. Okay? So, what are we thinking here? It's going to be decreasing.
It's decay.
Mm-hmm. It is decay. What's my graph looking like?
And one of these.
I think he's doing opposite of what you two are doing, and I don't know if
I
Taylor's
said
doing.
an L, but like
Yeah.
not really an L. Just like
Yeah.
it goes the way of an L.
Okay. And it's shifted down 3, so like that idea,
That's exactly what I was thinking.
okay? And that has to do with because this e value, I mean, that's the only thing we have is you could think of this as a reflection across the y-axis, and that's what our decay is there. So as x approaches negative infinity, what's our answer?
-3. No, I mean infinity.
Other way. Okay. Yeah, this is where, in pre-calc you guys kind of, I really want you guys to know that those 12 graphs we did in lesson 1.2 or 1.3 or whatever.
The ones we had to memorize?
Yeah, this was one of them.
No.
Yeah.
What was in my head then?
No.
It was.
Telling me now.
Okay. Do we have time for one more or not?
No.
No, we have 2 minutes.
We got there.
So Monday,
Time flies.
our brains are going to be in this exact same spot.
Okay.
We're going to be able to just pop right into this, yes?
Maybe.
I know, I'm kind of worried about my brain even, so. Okay, we will stop there though. We still have several more things to do. So, you can start into some of homework probably.
Yeah.
It's Friday.
I get it.
I don't want to know it.
The Tuesday.
Well, it's the stuff that we like.
Well, there's only so much you can do though, actually, now that I look at it.
School is Monday through Friday, 8 to 3. After that, I'm locked out.